The process can be broken down into a couple of steps when you're trying to name a carbon. The first thing you need to do is you need to count the longest continuous chain. So I'm going to add some words here. We're going to go with the longest and continuous chain. And that means that they are all in a straight line. So if you have 3 carbons or 4 carbons or 5 carbons in a line, that would be your longest continuous chain. And you can bend if you happen to have carbons in a row. For instance, if we come up here to the top, you could have carbon, 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 and then we have some more carbons working their way down. Our longest continuous chain up here would be 1, 2, 3, 4, 5. Okay, so that would be a 5 carbon chain. And it doesn't matter if it's in a bend, but it's a continuous straight, it's a connected line. So what you do is you count the longest continuous chain, and then you go to the parent name. And so we are going to, in both of these cases, we're going to use the group name pent, because we have 5 carbon chains. So your possible choices are meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. And so if you have a 3 carbon chain, it's a prop group. If you have an 8 carbon chain, it's an oct group. And that makes sense. The next step is to pick the ending that matches the groupings that are on there. If you have all single bonds, you're going to have an ANE ending. If you have a double bond, you're going to have an ENE ending. And if you have a triple bond, you're going to have a YNE ending. If you have an OH group, that's usually OL, like methanol. And there can be multiple other groups, which I'll show you later on in the screencast. Now, in the cases where you have a double or a triple bond, you want to locate this at the lowest spot in the count of the carbon change. So lowest number on the carbons. So let me show you what that looks like here in the next slide. Okay, so a couple brief lessons about counting your chain and locating branches and doubles or multiple bonds. Anything you're trying to have your continuous chain counted in a way to have it on the lowest number possible. Okay, so let's look at that in these examples. We have 5 carbon chains, so these are both pents, and they're all single bonds, so this would be a pentane. Okay, so in our first example here, we have the choice of 1, 2, 3, 4, 5. So that one's pretty simple. It really doesn't matter which direction we count our carbon chain in, left to right or right to left. In the second example, we can count a 1, 2, 3, 4, but that doesn't get me very long. We can go 1, 2, 3, 4, 5, or we can go 1, 2, 3, 4, 5. So this is a 5 carbon chain, and it really doesn't matter, again, if I count it left to right. Let me show you an example where it would matter. So we have a 5 carbon chain, and on this carbon we have a double bond. So if we count it, we can count 1, 2, 3, 4, 5, or we can count left to right, 1, 2, 3, 4, 5. So our double bond is either between carbons 2 and 3 or between carbons 3 and 4. So the lowest possible location of this example would be between carbons 2 and 3. So we would number in a way to get our double bond at the lowest spot. And so this example would become pent still because it's a 5 carbon, and we'd have our ENE ending to represent the double bond, and then we're going to tack on a 2 telling us where the double bond is connected. So this example is 2-pentene. Pent meaning 5 carbons, ENE meaning a double bond, and it is located on the second carbon. All right, back to our steps. So step 1 was count the longest continuous chain and come up with the group name. Step 2 is coming up with the ending, and step 3 is adding the substituents or groups to it. So sometimes you can have carbon groups attached. Sometimes you can have things like halogens, and sometimes you can have functional groups. Functional groups is a whole nother slide, which we will come back to in a bit. A chloro group is simply just a Cl attached. A bromo is a Br. Carbon chains, you can have a 1 carbon chain, a 2 carbon chain, a 3 carbon chain. And so we go back to the carbon branches, like 1 carbon is meth, 2 carbon is eth, 3 is prop, and you just name the group and attach it. So what you'll need to do is, if you have your 3 carbon chain with a chlorine off the side, we would have 2 chloro, methyl ethyl prop, and they're all single, so propane. And that 2 is telling me where the chlorine is attached. In the case of this example, I have 1, 2, 3, 4, 5, and it doesn't matter which direction I get it. So I have a 5 carbon, so I have another pent, and it's all single bonds, so pentane. And on carbon 3, I have a 2 carbon group, so that is 3, I'm sorry, it's not meth, it's ethyl pentane. And that would all be one word, so let's rewrite it. 3 ethyl pentane. Now, if you have more than one carbon branch, you can have, let's do another, we'll do a 4 carbon group, and we'll have a carbon off of both sides. So this is a 4 carbon group, this is butane, and we have 2 single carbon groups, so they're both methyls, and there's 2 of them, so dimethyl. And they happen to exist on, let's see, 1, 2, 3, 4. So they exist on carbon 2, 3 dimethyl butane. So you can have lots of different components attached. Remember, the goal is to have the branches at the lowest numbers on the carbons. And if you have a multiple bond, that will always have priority. What do I mean by that? I mean that if you have the choice between locating a branch at a low number or a double bond at the low number, you will go with the double bond.